All right, I'm smiling because this is actually one of the most fun in terms of lessons and student diagnoses kind of things that you can see with your students. It's a really good indicator of who has stick-with-itness and who needs support when they come across a hurdle. So this is a Paralax lab, and in the Paralax lab, I have a setup of cones outside. Now, I go through during the space introduction, I talk about parallax, I talk about measurements in space, I talk about precision, movements, and measurements, and this really drives it home. So I have, before class, gone out into a large area outside of our classroom, outside usually, and I set up a few cones, two on the outsides, one a little bit higher in the middle, and then two more that are not similarly distanced, but like on the farthest side of the field that I use. Now, the students are only allowed to stay along this baseline, and that measures like the two sides of Earth's rotation around a center point, the sun. So the worksheet that you'll see here has an example template on one side, and the other side is for the students to be doing their calculations on. It has a walkthrough using the tan function so that they can do that. Your students may or may not have, by the time they get to you, or by the time you run this simulation in grade 10, they may not have even done this kind of math yet, even though it is part of the Math 10 curriculum. So you have to be aware of that. Some students, if you're in a semestered school, may have done it, some may have not. But basically, you're measuring the distance with a protractor, and I let the kids use their phone and the measure app on their phone to measure the baseline, or you can give them meter sticks, or you can tell them to estimate or whatever. So once they go, they have to, with only going along the baseline, measure the distance to this cone here in the middle. The kids that think they get this distance in the middle go to measure the outside star distances, and that's the idea of this. Now, it is hard. It is really hard. Some kids have a hard time just with figuring out that they need to measure the baseline distance. Some kids have a hard time remembering how to use a protractor, and that's always fun to watch. They like hold it up like this and like they're trying to figure out how it works. It doesn't work. So you may have to go and do a rudimentary lesson on how to use a protractor. But the point is in this that they try and calculate the distance from the baseline to the nearest object, with the nearest star. And the comeback from this, after they talk about the struggles, after they talk about the challenges that they had, what worked for them, what didn't, the whole point is that we're trying to measure distances to something that's relatively close. Like you're talking like 15 big steps or something like that away from them. But they'll give you measurements like 6 feet, and even though they've been working in meters, or they'll give you even 6 meters, but it's closer to 15. And so they have no concept of distance, or you'll see that kind of thing. But the ultimate point of this is that with this activity, you're teaching them that precision matters, not only in science, but especially when you're trying to do measurements in space. And this is a really good time to go and find a telescope picture where they have like one of those laser beams shooting into space, because they use the laser beams to point to objects that they know the distance of, that they've calculated the distance of, and they use that to like determine where things are in space related to them. It's just a precision measurement kind of thing, and it teaches them how parallax works and how measurements work at great distances, where, you know, the fractionist part of a degree will matter in the ultimate run. And you can tie it into like space travel, where object A is moving this way on an arc like a planet, and you have to launch so that you meet at this spot, or even just docking at the ISS, right? Anything like that. So there's lots of tie-ins here that you can bring up, but the process or the sheet is really just to help kind of solidify that fact that, you know, precision's important and you have to be paying attention and thinking. So I hope you try this one. Let me know how it goes, and we'll go from there. Okay, thanks. Bye.